Hello students, welcome back to SGC online chemistry classes. This is lecture number 7 on the topic classification of elements and periodicity in properties. Well students, in the last video you all have come to know regarding the definition of atomic radius, followed by the three other radius terms: covalent radius, van der Waals radius and metallic radius. Let's continue the part in the today's video, in the today's class, with the heading, after collecting the definitions of atomic radius and other three radius terms, let's look the trend. Let's look about the trend of atomic radius in the periodic table. How does it vary along the period and down the group? So how does this atomic radius, one of the periodic property, how does it vary on moving from left to right along the period and top to bottom down the group? Let's discuss in the today's class. Come on. The title starts with variation of atomic radius, variation of atomic radius in periodic table, variation of atomic radius in a periodic table. Let's check first with how does it vary along a period. How does this atomic radius vary along a period? Well students, for your kind information, generally the atomic radius of elements in a period decreases on moving from left to right in the periodic table. It decreases generally in a period, it decreases on moving from left to right. It is because of the two reasons. Let's collect. Generally atomic radius of elements decreases on moving from left to right, in a period. Let's repeat. How does this atomic radius vary along a period, in a period of the periodic table? Generally, atomic radius of any element that decreases on moving from left to right in a period. This is due to the following reason. First one, increase in the nuclear charge, due to increase in the nuclear charge, of elements, increase in nuclear charge of elements by 1 unit, followed by electrons. Electrons are entering into the same shell. Electrons are entering into the same valence shell or valence shell. One and the same. Well students, as I said, What about the variation of atomic radius along a period? Atomic radius of any element in a period that decreases and moving from left to right in the periodic table. This is due to, remember these 2 points, increasing nuclear charge of an element in a period and followed by electrons are entering into the same valence shell. Well students, because the increase in the nuclear charge of an atom of element and the electrons as they were entering into the same valence shell, what happens? Due to increase in the nuclear charge, as the electrons are entering into the same valence shell, the attraction between the valence electron and the nucleus that increases. The attraction between the valence electron and the nucleus increases, which results in the decrease in the atomic size. As the attraction between the valence electron and the nucleus increases, consequently what we notice, because of increase in the attraction between valence electron and nucleus, the atomic size decreases. That means atomic radius decreases. That we shall look in the elements of second period elements of the second period of the periodic table with the table, which we can notice in the atomic radius of the second period elements. Let's see the table. This table help one to understand get convinced with the variation of atomic radius along the period. As shown by second period elements. Example are second period elements. First element, first column, which is the elements column, element. Next is the nuclear charge. NC stands for nuclear charge. Third, valence shell. And the fourth one is atomic radius in terms of picometer. Atomic radius in picometer, measured in picometer. Well, element of second period begins with lithium. Beryllium, boron, carbon, nitrogen, oxygen, fluorine, except the noble gas elements, which we talk later on. Nuclear charge of lithium +3, that of beryllium +4, +5 boron, +6 carbon, 7 nitrogen, oxygen +8, then fluorine +9. Valence shell. What is the valence shell? So it is a 2s1 of lithium, 2s1, beryllium 2s2, boron 2s2, 2p1, 13 group. So 2s2, 2p2, carbon, nitrogen 2s2, 2p3, oxygen 2s2, 2p4, fluorine 2s2, 2p5. So the first elements of second period, nuclear charge, valence shell. Now last point, observation. How does the atomic radius value changes? Let's see. Atomic radius of lithium 152 picometer, that of beryllium 111 picometer, boron 88 picometer, carbon 77 picometer, nitrogen 75 picometer, oxygen 74 picometer, fluorine 72 picometer. So this table that gives the variation of the atomic radius on moving from left to right in the periodic table, left to right in the period of a periodic table. See, the element of second periods, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, except here I have not mentioned about the 18th group element, noble gases not given there, which is an exceptional case. Now these are all the atomic radius values given. Atomic radius of lithium 152 picometer, beryllium 111, boron 88, carbon 77, nitrogen 75, oxygen 74, fluorine 72, which you can notice from the magnitude of atomic radius. What you moving along the period, you notice this magnitude indicates that the atomic radius are moving from left to right, in a period it decreases. Why it is so? Because of increase in the nuclear charge of an element. See, you can notice increase in the nuclear charge 3 lithium plus 3 with 4 electron plus 4, 5 plus 5. So the nuclear charge increases along the period, followed by the electrons are entering into the same valence shell. 2s2, 2p1, same valence shell. As the electrons are entering into the same valence shell, the attraction of the valence electron and the nucleus increases. That results in decrease in the atomic size or atomic radius. This is how. So that we shall also show by graphically, as in the NCERT text, which is shown graphically also by plotting a graph, the magnitude of two values. One is the atomic radius along the y-axis, atomic radius in picometer plotted along y-axis, and the atomic number along the x-axis. I am plotting this. So I am plotting a graph between this. One can notice a graph or a curve of this kind, which was gradually decreasing. Like that, it was gradually decreasing. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, so on. The graph. This graphically one can notice, and moving along the period, the atomic radius that decreases. Lithium with the highest atomic radius, fluorine with low atomic radius. As the atomic number increases along the period by 1 unit each, the atomic radius which decreases. Generally it decreases. The reason is increase in the nuclear charge and the electrons entering into the same valence shell are the two causes behind decrease in the atomic radius of any element in any period or moving from left to right in the periodic table. So this table and this graphical notation help us to understand the trend of atomic radius. Here the element of second period in graphical representation that clearly indicates the variation of atomic radius along the period. Let's go to collect how does this atomic radius that vary in a group. Next part. How does this atomic radius. How does this atomic radius that vary in a group? In a group. Let's say in a group, the atomic radius of the elements, the atomic radius of the element increases. Atomic radius of the element increases. I am moving from top to bottom. I am moving from top to bottom. I am moving from top to bottom in a group. In any group. In any group. So, slightly, if one of the trend, if you remember, along the period, if you remember the contrast, we can apply for the group. What about variation of atomic radius in a group? Generally, the atomic radius of element increases and moving from top to bottom in any group. This is due to, let's see, first part. This is due to, you can account a reason. This is due to number one, electrons enters into new shells. Enters into new shells. One of the reason. Though the electrons are entering into the new shells, even down the group also, as electron entering into new shell, the nuclear charge also increases, but magnitude of nuclear charge, magnitude of increasing nuclear charge, magnitude of increasing nuclear charge, increasing nuclear charge gets compensated by screening effect. Or shading effect. Let's say, what about the variation of atomic radius in a group? Generally, in any group, the atomic radius of the element increases on moving from top to bottom due to electrons entering into new shells, followed by the magnitude of increase in the nuclear charge will get balanced, counter-attacked by the screening effect. We will collect what screening effect in our next discussion. Screening effect is also called shading effect. We shall discuss it. So, these are the two reasons by which the atomic radius increases down the group. Let's take for convincing, for understanding the trend in the first group elements. Let's take the first group elements. Let's consider the first group elements. How does this atomic radius vary in the numbers of first group elements? Almost stable, same. Let me change with this, that. First group elements. Lithium, sodium, potassium, lithium, sodium, potassium, rubidium, cesium, francium, radioactive element. Nuclear charge plus 3 plus 11 electrons plus 19 plus 19 plus 37 plus 55 plus add 32 plus 87 nuclear charge. Valence shell. So what is the valence shell of lithium? Valence shell 2s1, 3s1, 4s1, 5s1, 6s1 and the francium 7s1. Let's take the magnitude of atomic radius of these elements. Lithium atomic radius in terms of picometer, lithium atomic radius is 152 picometer, sodium 186 picometer, potassium 231 picometer, rubidium 254 picometer, cesium 262, francium being radioactive, we have a gap for an exceptional case. So these are the atomic radius value of the elements belonging to group 1. Lithium, sodium, potassium, rubidium, cesium, francium. Get the picture of periodic table. So lithium atomic radius 152 picometer, that of sodium 186, increased by nearly 34 units. Next, by almost 35 units, potassium 231, rubidium 244, cesium 262, picometer, francium kept blank. So graphically, even if we can check the trend of this atomic radius by plotting these values, graphically one can see a trend of, as we notice the trend along the period, it is atomic radius in picometer, radius in picometer along y-axis, atomic number plotted along x-axis. So one can get a curve. One can get a curve of the kind. If we go with the curve, we can get a curve of this kind. So lithium, sodium, potassium, rubidium, cesium. So this is how the trend one can notice. This graphical representation also indicates on plotting atomic radius along the atomic number in a group, the curve shows to be a peak which is going in an increasing order. This is how the atomic radius of elements in any group that increases and moving from top to bottom in a group due to electron entering into new shell. And though the electron enters into new shell, though the nuclear charge also increases moving down the group, but the magnitude of nuclear charge and the screening effect overtakes the increase in the nuclear charge. Thus, the atomic size that goes on increases and moving from top to bottom in the periodic table, in the group of a periodic table. Hello students, before we conclude the trend of atomic radius along a period and down a group, let's collect highlights, important curve. The atomic radius of elements in a period decreases and moving from left to right in the periodic table, and the atomic radius of the elements in a group are moving from top to bottom, that increases. So as the table is given there regarding the atomic radius of halogen atoms, not mentioned in the table also. Dear students, do remember the not halogens, atomic radius of the noble gas elements. the noble gas elements, they do not possess the atomic radius because the atomic radius corresponds to a covalently bonded atoms. Because of their complete valence shell, they do not show a tendency to form a covalent bond. Therefore, the noble gas elements are associated with the van der Waals radius but not the covalent radius. Therefore, as an exception part, if you take the van der Waals radius of all the noble gas elements, which is quite larger in their size. So this is what exception. Regarding the screening effect, so what is this screening effect? As you go down the group, the electrons are entering into the new shell. As the new electrons are entering, nuclear charge also increases. But the magnitude of increase in the shell that dominates over the increase in the nuclear charge of an element. That's why there we notice, though the nuclear charge increases, the atomic radius will get increased because which gets compensated by screening effect. So what is this screening effect? The electron which are present in the inner orbit, will protect the electron present in the last orbit from the nuclear attraction. In one word to repeat. So what is screening effect? Screening effect, it is an effect in which the electron which are present in the inner orbit of an atom will protect the last electron, its last electron, from the nuclear attraction. That means the valence electrons will become inactive. They become inactive, not involving in the chemical reaction. That's what the reluctance of valence electron by the influence of inner electrons, what is called a screening effect. Because the screening effect dominates over the nuclear charge, which results in increase in the size of an atom and moving down the group, any group. Well, with this conclusion, let us go to the another periodic property, second periodic property, which is ionic radius. What it is? Ionic radius. Ionic radius. Well, students, before we go to collect the definition of ionic radius, let's understand what it corresponds, what it related to. Remember, ionic radius is related to the ions of a ionic compound. The ions of a ionic compound. So, as you know, ions, how the ions are going to be formed in our study, in the earlier study, you might have come to know the formation of ions. So the ions are of two kinds. Positive ion called cation, negative ion called anion. Let's see how the positive and negative ions are going to be formed. First and foremost, the ionic radius, which is related to the ions of an ionic compound. So how these ions are going to form? Let's understand the first. If you take a neutral atom, say X is a neutral atom. Suppose if it loses one electron, suppose it loses one or more electron depending upon its nature or electropositivity. Say this neutral atom loses one electron, which loses one electron gives you its ion with loss of one electron, say with loss of one electron. So this is a neutral atom, X is a neutral atom. X plus is an ion. This is a positive ion. So positive ion, what is called cation. What it is called? Cation. And the second part, if the neutral atom, X neutral atom, if it's gain one electron, if it's gain one electron, one or more electron depend on its nature, gives its X minus. Here X is a neutral atom, while X minus is an anion. Thus I conclude with these two representations. So how the cation is formed? It is formed by the loss of one or more electron from the neutral atom. It is a neutral atom. X is a neutral atom. X is neutral atom, or simply atom. So atom, neutral atom. Whenever one or more electrons are going to lost by an atom, those are going to give you cations which carry a positive charge. Whenever a neutral atom gains electron, that gives its new ions are formed called anions, which carries a negative charge. Thus, before we go to collect the ionic radius definition, I think it is essential to know how these ions are formed. I conclude in one sentence: whenever a neutral atom loses one or more electron, form its or gives its positively charged ion called cation. And while when it gains one or more electron, that is going to give a negatively charged ion called anion. As a point of note, you should remember. Hope you have come to know from your earlier study. When you take the size, radius size, so x is going to larger in size. Neutral atom is going to be larger in size than its cation. Do remember as a general essential point. Regarding the size of anion, X minus is larger in size from the atom from which it is formed. So I can conclude these two symbolic representation by the terms. The size of neutral atom is larger. The size of neutral atom is larger than its cation. Second, the size of anion is always larger than its neutral atom. I repeat, the radius of neutral atom is larger than its cation from which it is formed, or cation from the neutral atom it is formed, and the radius of anion is larger than its neutral atom. This, keeping in this in the mind, let's go to collect the definition of ionic radius. What ionic radius means? Dear students, ionic radius may be defined as the distance between center of nucleus of an ion, and a point up to which the distance between the center of, the distance between the center of nucleus of an ion, and a point up to which the electron cloud has influence on it. The distance between the center of the nucleus of an ion and a point up to which electron cloud has influence on on it is the definition of the ionic radius. I do repeat, what is ionic radius? Ionic radius is nothing but the distance from the center of the nucleus of an ion and a point up to which the electron cloud has influence on it. Electron cloud has influence on it is the definition of ionic radius. Let's understand its trend. The trend of ionic radius along the period and down the group. Remember, ionic radius which goes on decreases. Ionic radius goes on decreases along a period. And this ionic radius will increase down the group. This trend one must remember. What is this ionic radius? The distance between the center of nucleus of an ion and a point up to which the electron cloud has influence on it. So what about the trend of ionic radius in the periodic table? Ionic radius that decreases along a period, while the ionic radius increases on moving down the group. If we take an example of a crystalline solid example, how this ionic radius calculated. If we take an example of a sodium chloride crystal, for this, which is consisting of two ions, sodium ion and the chloride ion, the internuclear distance from the X-ray, studies, the internuclear distance between these two ions, between Na plus and Cl minus, was 276 picometer, The distance between the Na plus and Cl minus was 276 picometer. Well, students, the example of a sodium chloride crystal. As sodium chloride ionic compound consisting of two ions, sodium ion and chloride ion, the internuclear distance between sodium and chloride ion by the X-ray studies was found to be 176 picometer. The ionic radius of sodium ion was found to be 95 picometer, and that the ionic radius of Cl minus, which was found to be 276 minus 95, 181 picometer. This is how the ionic radius, which corresponds to the ions of the ionic compounds, the ions, cations and anion of ionic compounds. Let's conclude. What is ionic radius? Is the distance between the center of nucleus of an ion and a point up to which the electron cloud has influence on it. Now, what is the trend of this ionic radius? It decreases along a period, same as that of the atomic radius, and increases down the group. The same reason we can account for the ionic radius too. Now, let's collect some of the characteristics of the ionic radius. What are the characteristics of ionic radius? Let's collect one by one. Characteristics of ionic radius. Characteristics of ionic radius. Ionic radius. First one. The radius of cation. First one. The radius radius of cation is smaller. Radius of cation is always smaller. Is always smaller than that of neutral atom. What is the characteristics? I said already symbolically, but written in sentence. The radius of cation is always smaller than that of neutral atom. Let's take an example, which is Na, sodium neutral atom with atomic number 11. That gives or forms sodium ion with loss of 1 electron. I'm checking the atomic radius value, the ionic radius value. The radius of neutral atom, sodium, is, which was found to be, as just now in the table you collected, which was found to be 154 picometer. Neutral atom it is, While that, now it is an ion, sodium neutral atom, sodium ion. So the cation size is going to be decreases as per the characteristics. The radius of cation is always smaller. What was the radius of sodium? Which was noticed 95 picometer. Thus you can correlate with the magnitude. The radius of sodium is 154 picometer. Radius of sodium ion, which is 95 picometer. Thus the radius of cation is always smaller than that of neutral atom. Point 2 or characteristics number 2. Contrast with the anions. What you can write? The radius. What is the point? The radius. The radius of anion. The radius of anions. The radius of anion is always larger, greater in the sense larger, is always larger than that of neutral atom, So the anions, chlorine with atomic number 17 gains electron that gives into chloride ion, that forms what? Chloride ion. So with the gain of 1 electron. So when you take the radius of chlorine, in the table you recall what was the value? 99 picometer. And the chloride ion which is almost nearly double, 181 picometer. Thus it clearly indicates the radius of anion is always larger than that of neutral atom, while the radius of cation is always smaller than that of its neutral atom. These are the two characteristics. So do remember the point of characteristics. Radius of cation is always smaller than that of the atom, and the radius of anion is always larger than that of the atom. Well, so this is what regarding the characteristics of ionic radius. Now let's go to the next heading, which is a very important terms will arise, and is isoelectronic species. A question has appeared in the theory as well as in the CET over this part: size of cation with the neutral atom, size of anion with the neutral atom. Do remember which has appeared in the CET question. CET paper regarding their size and regarding the concept of isoelectronic species. The term itself says isoelectronic species. Let's collect the meaning of isoelectronic species in further discussion. Let's take the concept of isoelectronic species. The word itself says, what isoelectronic species? It is the species of different atoms or ions. The chemical species of different atoms or ions which contains same number of electrons, in them are called isoelectronic species, as the title itself says. Iso, same, number of electrons, same number of electrons which are belonging to atoms of different elements. Now, this table will give you a brief picturization of the isoelectronic species or idea. Let's look over the elements. Ions were taken. Ion, nitride ion, C. Nitride ion N3 minus, atomic number 7, 3 minus, number of electron 7 plus 3, 10. Oxide O2 minus, 8 plus 2, 10. Fluoride 9 plus 1, 10 electron. Sodium, so 11 minus of 1. Since charge is 1, total atomic number 11 minus of 1, 10 electron. Magnesium, atomic number 12, 2 electron lost, 12 minus 2, 10. Aluminium 13, 13 minus 3, 10. So, the first row indicating about the ions: nitride, oxide, fluoride, sodium ion, magnesium ion, aluminium. Atomic number 7, 8, 9, 11, 12, 13. Now the number of electrons. Now you see, this is an ion of a nitrogen, ion of a fluorine, ion of a magnesium, but the number of electron is 10, 10, 10. The chemical species of belonging to different atoms are ions, but they contain same number of electrons are called isoelectronic species, which are called isoelectronic species. So here, from looking into this table, observe carefully, we can conclude, we can draw 3 conclusions. The following conclusions can be drawn. From this table, the following conclusions can be drawn. What are the following conclusions? Number 1. So, cation with greater positive charge, cation with greater positive charge, is smaller in size. Cation with greater positive charge is smaller in size. You can check. Number of electrons in the aluminium is also 10. Aluminium ion is 10. That in the magnesium is also 10. But you check the size or the radius. Ionic radius of magnesium is 65 picometer. Aluminium ion is 50 picometer. Even you can check the number of electrons in the aluminium ion is 10. That in the nitride ion is 10. But check the ionic radius of nitride is 171 picometer, and that of the aluminium is 50 picometer. Thus, the first conclusion, cation with greater positive charge, smaller in size. Second conclusion we can draw, anions with greater negative charge, larger in size, with greater negative charge are with greater negative charge are larger in size, bigger in size, larger in size. You can check. See fluoride ion F minus 1, oxide ion O2 minus, nitride ion 3 minus. Number of electron in fluoride 10, that in oxide 10, nitride 10. But the ionic radius of nitride 171 picometer, while that of fluoride is 136 picometer. This is how anions with greater negative charge, are larger in size. And one more point. Among the isoelectronic species, third conclusion, among isoelectronic species, anions are always larger than among isoelectronic species, anions are larger than cations. So I can show here. So if you take fluoride ion, number of electron 10, atomic radius 10. So sodium ion, number of electron 10, and the atomic radius 5. So what I can write here is, though the number of electron is same, but when you take among the isoelectronic species, these are all isoelectronic, anions are going to be larger in size than the cations. Anions are larger in size than the cations. These are the three conclusions what we can draw from this table. Well, students, with this concept of ionic radius, its trend and isoelectronic species, let's discuss about the next periodic property in the next.